just going to record. So method 4 here, we're halfway into it here. So we took the ln of both sides, took the x plus 1 out front by the power property. We distributed the ln of 11 on this side. Now we're going to distribute the ln of 7 on the other side. So this becomes x ln of 7. Make that better, right? Because we've got ln of 7 times x is x ln of 7, and then distribute to the negative 1, and it's minus ln of 7. Did I lose anybody? You with me? Distributing the ln of 11, the ln of 7, as if it's just a value. It is. It's just a number. Okay, now what we need to do is collect all of the ln's on one, all of the x terms on one side. Anything involving an x is going to be on one side, and anything not involving an x is going to be on the other side. So we can subtract x ln of 7 from both sides. And we'll subtract ln of 11 on both sides. So it'll cancel there. So on the left-hand side, I'm going to have x ln 11 minus x ln 7. And there's no way to subtract that. Those are not like terms, so there's no way to really subtract that. And then on the right side, I'm going to have negative ln of 7 minus ln 11. Now what we want to do is factor out the x. Remember, our goal here is to solve for x. We are trying to get x on one side of this equation all by itself. Keep in mind that that's always your goal with all of these methods, right? Trying to get x by itself. So that's why collecting all the x's to one side was a logical choice that we just did. Now we're trying to isolate that x. So in order to isolate the x, there's an x term in both of these. So we're going to factor out that x term. So when we factor out the x term, we get x on the outside of the parentheses, and inside we'll have ln of 11 minus ln 7. Right? Factoring out the x term, remember, if we multiplied this back out, we should get the line before it. Right? That line right there. So we factored out the x. On this side, we have this. Now, how could I get x all by itself? We're going to divide. Divide by this whole parenthesis. Whatever we do to one side, we have to do to the other side. Now, this is where there's some discrepancy among teachers and answer keys. Where do you stop simplifying? I could now condense my numerator and condense my denominator, and that would be ln of 1 over 7 times 11, right? Because there's a negative out front, so that 7 has to actually go on the bottom. And ln of 11 over 7 on the bottom of that. To me, sometimes this will help get something that's simpler looking. We're solving for x. No matter what, if we want the value of x, this will involve a calculator, right? I mean, nobody knows the ln of 7 off the top of their head. So it will involve a calculator anyhow. So my opinion is, once you get x isolated, if you have this in a form that you could easily enter into your calculator, then I think it's fine to stop there. You should know that it could be condensed, and that this could end up, I could keep going here, ln of 1 over 77 over ln of 11 over 7. This cannot be simplified any further. There's no such thing as, well, there's an ln on the top and there's an ln on the bottom, so we can just cancel those out. That doesn't work, right? So it could be simplified. So why am I telling you both of those? Well, because, let's say there's a multiple choice or something and you need to find the right answer. It might be in a different form based on how far somebody simplified or condensed or whatever. So you need to recognize that they're the same thing. All right, you guys want to try number 2? Oh, yeah, try number 2. Follow the steps. All right, so there's that one worked out. Let's go to the next method. Method 5. Method 5 is when there's only one exponential expression. And this is basically just converting your exponentials into logs. But in order to do that, you first have to isolate that exponential. So if there's anything with the exponential on one side, you have to get rid of it. Like if this said 4 to the x and then it was plus 5, we would have to subtract 5 from both sides first. You got to isolate the exponential first. So the method that they are recommending here is rewriting this in log form. So this would be rewritten as log base 4 of 13 equals x. You guys see that? Because if we rewrote it, 4 to the x equals 13. Well, now we solve for x. X is just log base 4 of 13, which we can put into our calculator. When we put it into our calculator, it's a base 4. So remember, in your calculator, you could do it as log 13 over log 4. That's the change of base formula. Equals x. And when you put that into your calculator, you'll get some sort of a decimal. And this says round to the nearest hundredth. Notice on some of these methods it said leave your answer exact, the exact form or whatever. That means leave it with the ln's and everything. If it says round, obviously, you're putting it into your calculator and you're getting the decimal equivalent. So just watch for the directions, whether it says exact or round. There's another way of thinking about this method. When you have an x or any variable in the exponent, remember we said that's why they invented logs? They invented logs so that you can get that variable out of your exponent. So this is one way of doing that, writing it as a log. You could also think about this as take the log base 4 of both sides. Right? Take the log base 4 of 4 to the x, and what do you get? Log base 4 of 4 to the x is just x. Right? Remember, if it's the same base, 4, and then 4 to the something, it's just that something. Log base 4 of 4 to the x is just x, and then log base 4 of 13. So we have x equals log base 4 of 13, which is what we just had. Right? So that's another way of thinking about this. Like here, Remember when we were solving those equations like the PERT formula, right? Continuous compounded interest. And we had e to the something. Well, what did we do? What did we do to get that something out of the exponent? We took the natural log of both sides. So you can think about this method, you really could think about it the same way. Take the natural log of both sides. What happens when we take the natural log of e to the something? You just get that something. But you have to remember that you had to take the natural log of the other side, too. So we're going to get the same thing when we use this method. In fact, I'm just going to leave that there. Oops, I erased part of it. So this method says rewrite this in logarithmic form. Well, if it's a base of e, rewriting it in log form is just ln, think of that as base e to the 4 minus 3x equals 6. So this is ln of 6 equals 4 minus 3x. Right? That's e to the 4 minus 3x equals 6. Well, see what we had here? 4 minus 3x equals ln of 6. It's the same thing. So you can think of it either way. You're rewriting it in logarithmic form, or you're taking the natural log, in this case, both sides. At any rate, once we get to this point, our job still is to isolate x. So what should I do? Subtract 4 from both sides. You get negative 3x equals ln of 6 minus 4. Now what? Divide by negative 3. And x equals natural log of 6, and push enter, minus 4, and then push enter, and then divide by negative 3. Be careful that you're not doing ln of 6 minus 4. That's different. This is ln of 6, then minus 4, right? And your answer here comes out to approximately, anybody get it? 0.74. Right, you guys try that last one. Method 6. So, this one, we've got an exponential in quadratic form. So what we want to do is kind of name our variable in simpler terms. The common way to do this is to use the letter u. I'm not sure why, but assign u an actual value. Our u in this case is e to the x. If our u is e to the x, then this first term is just u squared. You see that? E to the x squared is just e to the 2x. Make sense? So our first term becomes u squared. What's our next term? 6u, and then minus 16 equals 0. Well, now we can factor this. We've got u, and 8, and 2, positive 8, negative 2. So, what's u equal? 2 or negative 8. Now we just have to go back and remember what our u value was. And we'll plug it back in here. So e to the x equals 2. And e to the x equals negative 8. So in order to solve this, e to the x equals 2, how do we solve for x? What would you do to solve for x there? Yep. So you either take the natural log of both sides, or you rewrite this in natural log form. Rewriting this in natural log form is ln of 2 equals x. Taking the natural log of both sides will get you the exact same thing. So x equals the ln of 2. Do the same thing here. And that is extraneous, because we can't take the natural log of a negative number. All right, so you guys try number 2. Again, you can make your u e to the x, and then factor. Okay, so this one turns out to be u minus 2, u plus 4, and so it's natural log of 2 and natural log of negative 4, which is extraneous. And by the way, the natural log of 2, this says round to the nearest hundredth, so approximately 0.69 for both of these. All right. Don't forget that whenever you have to solve for x in an equation where you've got an equal sign and you've got some blah 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 on one side with x's involved and some blah 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 on the other side with x's involved, and you have to solve for x, there is always the option of using your calculator and putting the left side into y1 and the right side into y2 and pushing second calc intersect, and it will give you your answer for x every time. Now, I don't necessarily recommend that you solve all your equations by doing that, because honestly, sometimes just entering it into the calculator and finding the right window and everything, you could have solved it faster, just the regular method. But if you're on the SAT, let's say, and you like skipped one because it seemed really hard, and you get to the end, you have a little extra time, you go back, you try to do it, you can't do it. It's solving for x. You put y1, left side, y2, right side, second calc, intersect, boom. Circle the right answer. Okay, so it is an option. So that's what this method is. You've got your left side, you've got your right side. You can just push second calc intersect. So if we do that here, oops. The thing you want to make sure that you do is obviously enter it accurately. So my left side of my equation here is log base 3 of x plus log base 4 of x. I'm going to put that in parentheses. Log. Remember, math, alpha, math gives us that log. So we could just enter it nicely there. Log base 3. You got to arrow over of x plus log base 4 of x, and that's my left side of the equation. And on the right side, I'm just going to put y equals 4. And then I'm going to graph this, see what happens. I might need to change my window. Oh no, that's good. I can see the intersect there. So I'm going to do second, calc, intersect, first curve, second curve, 11.6869. So to the nearest hundredth would be 11.69. Wait, does it say? That's a 0. Thank you. I was like, wait, I have it wrong on my paper. I put 11.61 here. Yeah, sorry, that's a 0.69. So it's 11.61 is your answer. Approximately equal to 11.61. Now, why was this not only a good option, but a necessary option for this particular problem? Because one's a base 3 and one's a base 4, and we don't really know how to handle that, right? And over here, we've got a x as a term, and then we have an x as a variable, and we don't really know how to handle that either. So that's why these are good calculator problems. Okay, so I'm going to let you work now. We only have a few minutes left, but your homework is going to be to finish both sides of this practice. Whoops. There is a word problem at the bottom, which I would like you to try, but I'm going to kind of help you set this up a little bit right now. We're talking about a website and the number of hits it gets, and it grows exponentially month to month. So what you want to do is figure this is a 3-month period, which it is, and you're trying to figure out what that rate is. So this is the formula. It's just like the PERT formula, really, where n sub 0 is your initial amount, n at time t is the ending amount, and then it's e to the kt. Well, the k is that rate of growth, and then the t is time in months. Okay, so think of this as your initial amount, and this as your ending amount. And then I think you'll be able to kind of figure it out from there. 3 months? It's a T. Just end this right here. N of T.